So today we're going to talk about second degree trig equations, quadratics namely. I suppose they could go probably higher than that, but they don't typically. So we're going to we're going to start with ones where they're ready to be solved, and then we're going to go into more difficult ones where you have to do some kind of an identity swap before you can solve. So here we have a typical, maybe, trig equation, second degree. It's a quadratic. Sine squared x minus sine of x minus 2 equals 0. Just like you solve any other quadratic equation, first thing I would do is look to see, does it factor? The difference here is that instead of just x squared minus x minus 2, my unknown, my x, is a trig ratio, sine of x. But this parallels this. X squared minus x minus 2 equals 0. So if you know how to factor this, you split up your x. You got factors of 2 that have a difference of 1, and that's negative, that's positive. Then you set each one equal to 0 so that you can find your two values of x, and this is a beautiful thing. That's great. So here, instead of just x, it's sine of x. But it's the same idea. So I'm going to split up my sine squared of x into sine of x and sine of x. I'm going to take my factors of 2 that have a difference of 1, negative 1, whatever. And I'm going to have a 2 and a 1, and the 2 gets the negative and the 1 gets the positive. And so you can see how this parallels here. Sine x minus 2, x minus 2. Sine x plus 1, x plus 1. Next thing I'm going to do is set each of these factors equal to 0. So if the sine of x minus 2 equals 0, that means that the sine of x equals 2. Well, you know what? This never happens. Sine of x isn't 2. Sine of x oscillates from negative 1 to 1. So I'm going to reject this. This one here, if the sine of x plus 1 equals 0, then the sine of x is negative 1. Now when I put this into my calculator as an inverse sine of negative 1, the calculator is going to tell me negative 90 degrees. Problem. Because, oops, I didn't tell you the interval. We're going to solve these again from 0 to 360. Negative 90 is not in that interval. So I need to find the coterminal. Okay, so let me just write this in. When you do this on your calculator, the calculator tells you negative 90. We need to find the coterminal and turn it into 270. 270 is in the appropriate interval. Negative 90 is not. Now you can also take it off the sine curve, knowing that sine starts at 0, peaks at 1 at 90, 0 at 180, negative 1 at 270. So you can actually find that value off of your graph also. This is probably a little bit more typical for an example. What I'm going to end up with is I'm going to factor this. I'm just writing in my interval over which I'm solving. So again, if you can factor 3x squared plus x minus 2 equals 0, then you can factor this. If you are terrible at factoring and especially hate the leading coefficient factoring, quadratic formula will work here also. If I'm going to use the quadratic formula, I'm going to use 3 for a, 1 for b, and negative 2 for c. Okay, so let me show you how this factors first, and then we'll go through the quadratic formula. You can go through AC method, whatever you want to do, but it's basically 3 times the cosine of x times the cosine of x. I'm going to put my 2 here and my 1 here, and that's how I end up with my positive cos for the middle term, because positive 3 cos minus 2 cos gives me positive cos. So that's how it factors. And when I set this equal to 0, I'm going to end up with a cosine ratio. I'm going to take the negative 2 to the other side, make it positive, and divide by 3. So I get a cosine ratio of 2/3. And then here, I'm going to get a cosine ratio, when I set this equal to 0, of negative 1. Now this is an easy one, because that's a ratio I recognize. Cosine is negative 1 when x is 180. And that's the only time that happens in that interval, because it bottoms out at 180. Here, I don't have a nice ratio here that I know. It's not one I recognize from my chart, and it's not a quadrantal, so I'm going to have to go in and inverse cos this, and when I do that, I will get, because it's positive, I will get a positive answer. Again, let's go to the nearest degree, just to keep things simple. So the inverse cos of 2/3 is 48 degrees to the nearest degree. What I need to remember is that this happens twice in this interval, once in quadrant 1 and again in quadrant 4. So my first answer will be at 48 in quadrant 1. My second answer, if I take 360 and subtract 48, I will get 100, 12. That's a 112, by the way. So I have 3 answers. I have 2 from this ratio, and I have 1 from this ratio. What I want to do is gather them together in a single solution set. That's the best way to handle your answer. Same question. This time I'm going to take you through the quadratic formula. If I can refresh your memory on that quadratic formula, it looks like this. X equals, x being the roots. It's negative b plus or minus. Under the square root, it's b squared minus 4ac, and that is all over 2a. Now for this particular example, I will use 3 for a, I will use 1 for b, and I will use 2 for c. Here's something a little different. When I substitute now, I'm not finding x. X represents my angle. I'm actually finding the cosine ratio. And so one of the key pieces to using the quadratic formula is that when you substitute, you replace x with what trig ratio you're looking for, which in this case is the cos of x. And then that's equal to the negative of 1 plus and minus. Under the radical, it'll be 1 squared minus 4 times 3 times negative 2 all over 2 times 3. Be careful of your signs. So now I have cos of x equals negative 1 plus and minus. That's sloppy. Negative 1 plus and minus. Under the radical, it's 1 minus 4 times 3 times negative 2, which is a negative 24, and 1 minus negative 24. What I recommend is that you just take your calculator and plug that out, okay? So it's going to be a 25 under the radical, and that's over 6. So it's basically 1 plus 24 because of the negative and the negative, okay? Now that tells me, oh, perfect square, this would have factored. Too late, almost done. So keep going, and I'm going to get cos of x equals negative 1 plus and minus 5 over 6. Oh boy. Okay, so that is a 5. Now I'm going to separate my roots. The first ratio is negative 1 plus 5 over 6, which gives me a cosine ratio of 4/6, which is your 2/3. The other one is cos of x is negative 1 minus 5 over 6, and negative 1 minus 5 is negative 6 over 6, which is negative 1. So there's your 2 ratios. Then you take it to your inverse, and keep in mind, this is the one that led me to the quadrantal at 180, and then this gave me the reference angle of 48, and then also taking it into quadrant 4 was the 112. So I do get the same answers. 3 answers, 48, 112, and 180. A little bit different approach. I will tell you, in all honesty, most of my students use the quadratic formula for these trig, higher powered trig equations, only because they feel more confident with that than the factoring. Because a lot of times the factoring have a leading coefficient. So this one's a little different. I am going to find the tangent squared of x minus 3 equals 0. If that 3 was a 4, I could do the difference of 2 squares and factor it that way. But it's not, and so that creates a little bit more of an issue. So what I'm going to do, because there's a missing term, this is an incomplete quadratic, I'm going to actually move that negative 3 to the other side and make it a positive 3. And then I'm going to simply take the square root of both sides. What that will give me then, be careful here, because I know that there's going to be 2 ratios for this tan. It's going to be positive and negative square root of 3. So that means the tangent of x is equal positive square root of 3, or the tangent of x is equal to the negative of the square root of 3. Now keep in mind that each of these ratios has two angles. Tangent is positive in quadrants 1 and 3. Tangent is negative in quadrants 2 and 4. The beauty of this problem is that the tangent ratio of radical 3 is one I know. And from my special angle ratio chart, or from your calculator, if you inverse tan the square root of 3, the calculator will tell you it's 60 degrees. So because of that, because I know that my reference angle is 60 degrees across the board, in quadrant 1, I could tell you that the answer is 60. And in quadrant 3, I can tell you it's 240. In quadrant 2, I'm going to tell you that the answer is 120. And in quadrant 4, I'm going to tell you that the answer is 300. So again, I simply take each of those reference angles into the appropriate quadrant to find those angles. Now here's the thing. I go back up and I look at my interval, and it's in radians. So as long as I know that 60 degrees is pi over 3, I can now change each of these degree measures into radian measure. So 60 degrees is pi over 3. 120 is 2 60s, so it's 2 pi over 3. 240 is 4 60s, so it's 4 pi over 3. And 300 is 5 60s, so it's 5 pi over 3. And that is the answers in radians. Alrighty, we're going to practice more of these too.